Bingo, we are.
All right, we're good to go. Done.
Just double check.
Oh, just coming up for me now.
Yeah, we're good. Thanks, Sue.
Okay, not a problem.
Bingo, we are.
All right, we are now streaming to YouTube after some technical difficulties. Done.
Where's Bob Christmas? Yeah, I can see it streaming
Okay, we're good to go then. I didn't think we were.
live.
Okay. All right, I'm going to get started tonight. So as those of you who came in early, Bernie is not with us at this moment in time. He had a rather interesting adventure today with the truck. He went and did a delivery, and he was on his way home. He was actually at the 400 and the 401 when he got a call and said, no, they didn't want it delivered to the address that was on your list. They wanted it at this address. So you have to go back and move it. So he had to turn around and drive back to Aurelia and pick up the load and move it to where the customer wanted it. So that put him behind. So as Paula said, he is in his own car on Barton Street and he's heading home. So he should join us in a minute. But for now, I'm pinch hitting for him. So welcome everybody to the December meeting of the Hamilton Amateur Astronomers. I hope that everyone is well and looking forward to a very interesting night tonight. Just a couple of things. And to catch, our treasurer has, I think, Anne, did you put the financials in the EH?
No, they will be in the January EH.
Okay, so the financial statements have just come out and they will be in the January EH. And again, thanks to Bob for doing a wonderful event horizon this month, as he always does. At this point in time, I'd like everybody to please mute their mics for me. And you can turn off your cameras as well. And I'm going to introduce our speaker for tonight. So we'll give everybody a chance to do that. Bill, don't mute your mic.
No, can you hear me still?
Yeah, you're good.
Okay.
Okay, I'm just checking here. All right, it looks good to go. So tonight, everyone, we have Bill Burnett. I hope I said that correctly.
Mm-hmm.
And Bill is coming to us from Vancouver, which is one of the reasons that Zoom is so cool. We can have guest speakers from all over the place. We've had from Hawaii, and now we've got from Vancouver. Bill was born and raised in Vancouver, and he was educated at Langara College and the University of BC. He began his career in print journalism, but has always been interested in space science and space science writing. He's been an astronomy educator, an outreach organizer, and a planetarium operator. And I thought it's really cool because he became the first portable planetarium operator in the province. And I think a portable planetarium would be like very cool. As an observer of the night sky, Bill has a deep interest in telescopes and celestial observing, and communicating about astronomy has been a lifelong love. And I think he'd fit in perfectly with our club too, because that is the passion of a lot of people here. And he remains a regular contributor to the Nova newsletter from the Vancouver RASC group. And with that being said, Bill is going to talk to us tonight about the First Astronomers. Bill, it's all yours.
Thanks, Sue. Yes, well, usually when I give a talk, and especially since I've been a planetarium operator for so long, in a planetarium it's dark and you can't hold notes in front of you. So you have to know what you're going to be saying ahead of time. And that's always the case. However, this evening is a bit of an exception because the topic is partially novel, and I only finished writing it up yesterday. So I'm going to be referring to notes. You won't see the notes, but you'll probably get the idea that that's happening. It's not that I'm nodding off or anything like that. It's that I actually have a piece of paper in front of me, right? So with that, we begin the First Astronomers. Now, it begins with a kind of a question, and it ends with a question. And the question is, what is astronomy? Now, this question is never asked. People learn astronomy, take degrees in it. Money is allocated both in educating and entertaining people in astronomy. Buildings dedicated to the stars are built. Money is shot into space in the form of skyborne telescopes, while bigger and better light collectors are planned for the very tallest places on Earth, all in an attempt to see things better far, far away. Why? Astronomy can't be a necessity like growing food, so why is it done? Like many things, it turns out astronomy is not a physical requirement, but a collective cultural habit, like going to the movies or peeking over the edge at Niagara Falls. At least some people are doing astronomy, generally in pretty relaxed environments and with ever-increasing cultural prestige. How did this begin, and why is it still a current preoccupation? It turns out there's no real answer to this, but there is what astronomers refer to as a history of observation. This concept is taken from thumbnails in which an object's prior viewing and impressions of the eyepiece both enrich our understanding of an object and increase the enjoyment in watching it today. For example, the Sagittarius globular cluster M22 has an extensive entry in Kenneth Gwynne Jones' book on the Messier objects. It tells who was the first observer, Hevelius, but Halley and Messier both claim Abraham Ilhy first saw it in 1665, so it's a bit of a dispute. Thus, there are descriptions of M22 at the eyepiece by Webb, Lassell, Messier, and many others. We learn Harlow Shapley counted 70,000 stars in this rich mass, and that M22 is one of the closest globulars to the sun. All of these tidbits are handy and I hope interesting when I'm talking about it at the eyepiece to the public at a star party. Well, can we apply the history of observation concept to the whole topic of astronomy? This is different from a history of astronomy, which there's endless tracks, all very much the same. The history of astronomy usually is a kind of linear progression from early error to magnificent truth, culminating in a kind of endpoint amid current ideas and results. A great deal is missing from these linear narratives, the result of a strong tendency to see history as the culmination of concerns that are current right now. Thus, the past is seen as giving lessons in how history itself is marching towards the directions served up in the topics in daily newspapers. Much has to be dropped or sidelined in these accounts, purporting to show how former investigators were just like ourselves, only they didn't get very far since they were not identical with ourselves. A close look at the past shows concerns and methods very different than today. For example, a classical Greek problem in astronomy was, given all the constellation figures, Orion, the Twins, the Lion, and so on, are all directing their gaze westward in the direction they are going, and very sensibly too. So why does the bull insist on looking eastward against the direction of daily motion? Well, various explanations were suggested. It was said the bull was watching Orion for signs of hostility. Well, now what does modern astronomy say? Well, do the astrophysical investigators have a better answer or the definitive correct reason? Of course not. We no longer ask the questions, and if raised, one would be directed to the folklore or perhaps classical studies department. It's outside physics to ask such questions. By imagining the subject to be explained in astronomy at every time and place in the past was always the same, namely what we say it is today, we miss most of astronomy and relegate it to a murky and irrelevant shadow. So what were the interests and methods of the earliest astronomers? Some clue can be gleaned by jumping in media res, as the Greeks say, jumping into the middle of things. And so let's do that. Let's begin. our discovery of astronomy, not from the beginning or the end point, but about 2,400 years ago with the writer Theophrastus. This early Greek was a student of Aristotle and took over the master's job when Aristotle died. He is best known for the characters and attempt to describe human types, in which, however, is a resume of human imperfections and folly. So a long treatise on plants, it's the longest document we have, but the very short sky signs is also extant. He must have written an astronomy too, but it is lost. These sky signs tell of weather, but for Theophrastus, he makes no distinction between star and cloud. That's something we do, but not the early sky watcher. He starts with a note of the risings and settings of stars. Stars can go from visibility to invisibility in two ways. They can set at sunset, or they can be taken to set when the sun rises. Right, the latter setting is only a reference to a star meeting the horizon and winking out, but in any place in the sky and dimming out as the rising of the sun. In a similar and opposite way, the stars rise in two modes. The morning rising is when a star appears at night before the sun. Then there is the evening rising when at sunset the star is available in the sky. What is the value of these strange ways of noting rising and setting? Well, they only make sense if we consider the activity of the sky watcher who looks up without any equipment and is trying to view stars as they appear or disappear under real and not artificial conditions. The act of watching for a star to appear at sundown must have taken on an importance we no longer recognize. We're used to seeing sunset and the approach of stars as just a matter of fact without any specialness to this situation. The key to the method in Theophrastus is division by two. This comes perhaps by considering the bilateral symmetry of the human body. Right? So stone circles, sometimes called medicine wheels, take note of the two-fold display of the sky. Alignments pointing to the rising and setting of certain sky objects. So the appearance or disappearance of the star was at one time a sort of fundamental property of the star, like its spectral type is today. Once we have the concept of rising and setting down, Theophrastus moves quickly to a real example, the star Arcturus. Now, what are called the risings of Arcturus occur at both times, two times. His winter rising being at nightfall and his autumn rising at dawn. Now, of course, these aren't the real risings and settings of Arcturus today because of the precession of the equinox. So Arcturus is thought of as a spring star. And indeed, in the spring, I watch the Big Dipper and the handle arcs down and points to Arcturus. And then Arcturus rises up over the ground. And I have a look at it. Sort of tells me that the crocuses are going to come out and it's going to be spring. Okay, similarly, the Pleiades rise and set, dividing the year in two, and its appearance in the late fall warns sailors to beach their vessels against winter storms. The slogan, "Red Sky at Dawn," comes from this writer, and "Red Sky at Sunset" too, although I've never been able to remember which is good and which is bad, but it's another set of two. Solstices and equinox also divide the year in halves. For Theophrastus, change, such as a change in the weather, is key to a dividing line maintained by some sky event. Thus, he claims that the weather remains the same up until an equinox, for example, but then the weather changes. It waits for the equinox as a signal for some modification in circumstances. Of course, experience suggests the weather doesn't wait for an equinox or a solstice in order to change. Theophrastus knows that too, and has an ingenious way of explaining weather change in the middle of a season. The moon is subject to division, but not in its rising and setting, but in its phases. Change comes along a dividing line between new moon to full moon into stages of 4 days and 8 days. Full moon takes place at about 12 days after the crescent is first visible at nightfall. Thus the weather changes, but only in one of these measured steps and not spasmodically and without order. So this early way of bringing order to the cosmos with its simple principle of cause and effect and division into smaller units. For Theophrastus, these changes resonate not just in the sky, but they're guided by signs all around us. He says that it is a sign of rain if birds not normally found in the water decide to take a bath. It's going to rain. Another sign of rain is when toads take a bath or when frogs are vocal. The principle here seems to be that creatures Okay. Creatures associated with water, by calling attention to themselves, portend an onrush of water from the sky. Now, what comes after? Let's leave Theophrastus and move ahead almost 2,000 years. It's about 1400 AD, and the poet Chaucer is writing his Canterbury Tales. A good deal of astronomy is contained in the poem, perhaps more per page than any other English author. The astronomy of Chaucer is keyed to, again, subdivisions. But unlike Theophrastus, we need to be able to divide things by 12, a special number. The Egyptians divided the day into 12 hours, or 12 subdivisions measured by sundials, which were made available at least by 1300 BC. Then another twofold suggests another 12 hours by night, calculated by the changing positions of the stars. The 12 plus 12 gives 24 hours in the day, just as we use today. Ancient Middle Eastern number systems privileged the number 60, the first great number which holds divisors including 30, 20, 15, 12, 10, 6, 5, 4, 3, and 2. We still divide the clock into 60 units, and the degree is divided into 60 minutes of arc, and thus into 60 seconds of arc, to specify very closely the location of a place on the celestial sphere. The specialness of 60 is more than a fact of numerical significance, for these speculations live in a time when the number was an aspect of how nature operated, not by contingency, but in a formulaic way. For example, the classical writer Plutarch says the crocodile lays 60 eggs, incubates them for 60 days, and the offspring will live 60 years. Well, okay. He also says 60 is fundamental to those who watch the stars. The 12 signs of the zodiac have been mentioned. Sometimes the signs are spoken of as though the arrangement of stars suggests 12 figures. But I believe this idea is found only by those who read the statement in books and never go outside at night. The stars might have been arranged in some other fashion, and frequently they are in the zodiacs and constellation patterns of other cultures. In China, 29 divisions make the zodiac, one for each day's travel of the moon. This is found natural and normal in China. Notice that 12 is 60 divided by 5, as 2, the number we started with, is 10 divided by 5. In other words, 12 is to 60 as 2 is to 10. You might say that 12 replaces 2, or for our purposes, 12 becomes the new 2. Dividing the sky by 12 divisions, centered on the ecliptic, 12 signs of 30 degrees width form a circle of 360 degrees. Their names are familiar: Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, and Pisces. Originally, the zodiac was not a strip around the sky as it appears today, but included the whole of the celestial sphere, like the skins of 12 equally sliced cantaloupe sections. In this way of thinking, even the pole star is within a constellation of the zodiac, and the astronomical writer Claudius Ptolemy assigned Polaris to the sign of Gemini at 0 degrees, a sixth of a minute east of the initial twins boundary. The celestial sphere now contains 2 poles. Let's get one here. I've got a celestial sphere right here. Here we are. So the celestial sphere now contains 2 poles, the north and the south pole, an equator, and there's a yellow button on the top there. There it is. That's where the sun reaches the summer solstice, and the winter solstice is a blue button on the bottom, right? And so these are cardinal points in between. When they change positions, the sun moves across the equator. Those are called the equinoxes. Okay, so I have at least one high-tech thing to show in the talk. Okay, so in this way of thinking, the celestial sphere now contains 2 poles, 2 solstices, or places where the sun stands at maximum and minimum stations above and below the celestial equator, and not to forget 2 equinoxes where the sun crosses the equator. The whole sphere, with its assigned stars at fixed locations, is now joined by a subset of actors in addition to the moon and sun, the planets. The word has an interesting origin. It means to wander. Most dictionaries agree, but there is another sense in which it is to wander. It is related to the Greek notion of limited and unlimited. Today, we select unlimited as the preferred word of this pair, but the Greeks saw this as a mistake. The limited is better. From this way of thinking, something can only operate within a set of boundaries that define it. To step outside a boundary means to lose definition, and it is the fuzziness of overstepping boundaries that is the cause very often of a tragic trajectory. For example, Oedipus is the archetypical boundary trespasser. He is both son and husband to his mother. Our sense to side with boundarylessness, which is celebrated in this culture, is a result of the notion of individual autonomy and political freedom. But it encourages us to think there are no boundaries to individual achievement. Those who find limits against them are thought to be victims of oppression. The planets, therefore, are wandering in the wrong way. The fixed places of the stars are the normal situations of the sky fixtures, but the planets overstep and wander about, even though the planets have limits set by the width of the ecliptic band. Thus, the planets endure a set of moral judgments which derive from their motions as they move generally eastward among the stationary stars. A kind of anxiety arose in regard to these motions. Some skywriters refused to tackle the planets at all. Gradually, these various position bodies came to be subdivided themselves, but not by location itself, but by an imagined influence that might be falling on First Nations, and then after 300 BC on individuals. This pattern came to be called astrology. In astrology, the signs move around the sky, making one revolution in 24 hours, about 24 hours. A second sphere, wholly imaginary, divides the visible sky into 12 sections, but was immobile. The boundaries of this were thus the horizon, the zenith, and its opposite, the nadir. The establishment of these two spheres, which sweep past one another, is closely related to the concepts of altitude and azimuth against right ascension and declination. The astrologer watched the interplay of these two systems and also the planets. At the heart of astrology is the assignment of observational situations with so-called fates or tendencies. And key is the subdivision of the 12 sky parts plus location of planets, which make for further subdivision. The fixed system of strips of sky were said responsible for differing aspects of life. Personal appearance, disposition were governed by the first, while personal fame and fortune were the purview of the next. Other stripes affected parents, children, even servants. So if a servant was rude to you, maybe something bad had happened in that segment of the sky. As the signs migrated around the sky, planets operated as governors of the scene. The sun, moon, Jupiter, and Venus acted for the good, while Mars and Saturn were evil. Mercury sat on the fence and was sometimes good, sometimes evil, depending on its mood. All these delvings seem strange and foreign to modern thought, but two properties must be kept in mind. First, the sky is now ablaze with special sections, and the place of both stars and planets are specified to an accuracy never seen before. Locations of the sun and the moon in Chaucer are given even to a degree in the sign in which they occur. At some point, observations were made and tables constructed of planet and star locations. It is said a small mistake in the tables of sky events made Tycho Brahe decide to see if he could do better. Accuracy and assignment are thus two characteristics of the astrologer's art that would be inherited directly by the modern astronomer. At the all-important time of the 17th century, these tools would be picked up, but a shift would come in how the objects in the sky were considered. They became not signs of things in the earth. The grumpy servant was not this way because Saturn was in his house, but because he was always grumpy. Instead, the objects themselves began to be treated as though they had an individual identity. Now it becomes, how far away is Saturn? Right? The great accuracy backed by the certainties of geometry allowed very small areas to fit into calculations. For example, the amount of light striking Saturn's disk can be expressed as a portion of the sunlight filling the entire celestial sphere, and then the amount reflected back to Earth, where we see Saturn as an equal of the star of the first magnitude. Some algebra, and Saturn would only look this way if it were about 10 times more distant from the sun than the Earth is. Thus, the boundaries of the known solar system are found. Notice that the constellations, the degrees and declinations are all retained. It is the object of study that morphs, no longer the mysterious servant, but the planet as a place Telescopes increased the ability to examine even much smaller portions of the sky. And once they were set in use, new problems could be picked on that could only be tackled in the light of this new technology. Okay. And so the boxes remain, but are no longer filled with astrological explanations, but now come to be filled with emblems, such as mass, velocity, orbit, position on a curve, variation in brightness, and later chemical composition. We are now at the beginning of modern astronomy. Now, rather than racing to the end, let's go back once more over the ground covered and beyond. We see astrology in Chaucer's time with its sectioning off of the sky and measures of place to tell of the events on the earth. Before that, it was Theophrastus with his simple division of rising and setting. He uses the horizon, while the late astrologer, in effect, makes a set of horizons up in the whole sky and in 12 divisions. But what comes before the early Greeks? If we travel backwards, we find simpler divisions and more anthropomorphic designs. An example, the four winds got together for a feast. They were the north wind, the south, the east wind, and the west wind. Each one spoke of how strong a tide of wind they could make, how strong and how swift they could send their breezes. At last, they began to argue over which wind was the strongest. After some huffing and puffing, the four winds agreed to a contest. Each would be confined in a strong bag made of hide, but at a signal, each of the four would come racing out. Pelican was selected to be the judge of which wind was the strongest and fastest. The bags were prepared, and the test was set for certain days when the soothsayers said strong gales might be expected. Before the race, the south wind approached Pelican and said, "Take some stones and place them in the bags of the other three to slow them down so I can win. If you do this, I will give you many fish, enough to fill your beak." The Pelican agreed. The day of the contest arrived, and the four winds were nestled inside their bags. But beforehand, Pelican had been busy gathering stones from the shore. Yet when he came to place the stones in the bags, he forgot to leave the south winds empty. He placed stones in the south winds and the others, but then he ran out of stones, and the north wind had no stones in his bag. The race started, and the north wind easily outpaced the rest, whose winds were slowed by making the stones fly through the air. The stones raced through the air and became heated by the speed of their transit. They can still be seen in the sky as the stars, eternally flying in their unending flight through the sky. After the race, Pelican asked for fish as his gift from the north wind. The north wind gave him one fish, then another, and with each fish, Pelican's beak grew fuller. At last, after 2 weeks, the beak was full with 4 fish, but the south wind was still angry with Pelican, and so after his beak was finished, started taking the fish away, one at a time over the next 2 weeks. This adding and subtraction we can see for ourselves. When the moon is new, Pelican takes on his fish, and as the moon gets greater every day until it is full, then the moon starts to decline as the south wind takes back the fish, and so at the end, the moon has no fish and is invisible for a short time. But then begin a new series of moons, beginning as the north wind once again places fresh fish in Pelican's beak. So the thing repeats itself over and over again. I'll bet, as you heard the story of the Pelican and the four winds, you probably thought this sounds a bit familiar. Isn't it like a First Nation story, or like the ones collected by anthropologists? It's not really. I made it up. So let's see what the tale tells us. First of all, the astronomy in it speaks of 2 things: the origin of the stars in the stones, red hot and flying through the air, and the origin of the phase of the moon, which is the pelican's beak being recharged and then denuded of fish. But the heart of the story seems to not to involve stars at all, but a moral stance. Should one be punished for making a mistake? Is a mistake like purposely doing wrong, since the outcome is the same? Pelican is punished by the south wind, but rewarded by the north wind. Each month, the reward is given and then canceled. The story tells of real-life situations where differing interests compete, cannot be reconciled because something in the nature of reality itself opposes a compromise. The star and the moon stand as actors in this drama and reinforce the notion of a continuous display, which is a result of a specific act. I use the word drama in the last sentence purposely, for a tragedy involves opposing interests that for some reason transcend the ability of the parties to come to terms with. The universe itself and our world contains pitfalls that are built into the workings of the world itself. This is the essence of the tragic and the meaning of the four winds and the pelicans. The story seems to remind us of such stories. That's because there's a cultural congruence between all cultures which make narratives. All narratives spring from common sources, although we cannot specify exactly what the sources are. Otherwise, cultures would be incommensurable one with another, and understanding would be impossible. So, astronomy all along has the same subject in view, the local concerns. It's a mistake to think astronomy approaches an absolute truth and will find it out in the end one day, the definitive answer never to be modified the way the cosmos goes. This notion is no more the case than the idea that the Earth moves against an absolute frame of reference in a Euclidean space. When the absolute frame was hunted for, it turned out it didn't exist. Each astronomy shows an individual concerns and values internal to themselves, which are then mapped onto the sky. This is no different today. The technological matrix in which wherein we live makes the sky seen into a locale for machinery to show itself. It shows itself when on Mount Palomar, a significantly larger telescope was built than any before. It showed again in the Hubble Space Telescope, and now a Palomar-sized scope may be placed far from the Earth to peek at the heavens from the heavens itself. It is tempting to suppose that each new capability springs up and the former paradigms are discarded, but this doesn't seem to be true. Years ago, but not that long ago, I was approached by a newspaper offering an astronomy column. At first, I was flattered and envisioned media stardom, but my hopes were soon dashed when I came to understand the proponent of this did not make the distinction between astronomy and astrology, and it was the latter that they were interested in. In the mind of the editor, astronomy consisted in advice columns filled with vague notions of planet locations, UFOs, Star Trek, and pictures from the Hubble telescope. He also believed that the space telescope, when wanting a close-up picture of a galaxy, flew to the object, snapped away, and then flew back. I told him that if that was true, I was very surprised. So the answer to the question posed at the beginning of what astronomy is ends with a conclusion that it has no fixed object, but instead is a projection, a net of relations used to handle and affect events on the Earth. That the move to a modern and technological astronomy is no different than previous attempts to enclose ourselves in a sky-born mirror of ourselves. There is no doubt that the Humans in Space program would not exist if, for some technical reasons, the astronauts could not be watched on television. Their predictable antics and more predictable statements are the contemporary version of astrological pronouncements. The always optimistic astronauts are celebrated hourly for accomplishments which will be forgotten the next minute. So, what kind of an astronomy do we see at the end of this process, at the conclusion of the little thumbnail star history that is not a history? I see astronomy as the furthering of memories attained outside in forest climbs next to a fire pit, where a slide projector sitting on a tree stump, a group comes to see pictures and hear a few words, very few words, on astronomy. Afterwards, in a parking lot with clear horizons, I set up a large telescope. People line up with the first in line at the eyepiece. I remember one evening in a remote provincial park in the Kootenays, I placed a 25-inch telescope up and was turning it towards Jupiter. I placed a second 17.5-incher up about 50 yards away. That scope was turned upwards towards the Ring Nebula. My guest host for the evening took charge of that telescope. It was John Dobson. For several hours, he went up and down the small ladder, keeping the ring in view for long lineups. And when each new viewer approached the ladder, he sized them up and had something new and pertinent and often funny to say to them. He was able to enter into the world of another and give information, observation, history, or philosophy all at the same time and keyed to the audience. He entered into the life of the audience, even just for a moment, guessed and directed their attention to what was essential and ignored the inessential. He wasn't a fan of constellation stories. When someone at the park asked him to tell one, he simply said no, and I had to jump in and tell a far-fetched star story myself. He wasn't, yet he was never pedantic, and all those who attended his talks always went home richer than when they came. For me, this is the heritage of the sky. This is the answer to what is astronomy. And I notice we still keep on top of all these paradigms that come from the past. And in here, I don't know if you can see this. This is the position. It's a little data list on the constellation, on the planets. So we have the planets' names are on one side, right? And then on the other side, whether they're up in the morning visibility or evening visibility, right? Just like Theophrastus. Then the constellation they're in, right? That's given as well. Then the diameter in arc seconds of the disk. This is a modern type of thing at the concern of the telescope. The magnitude that they are at, of course, with a modern magnitude scale, and the date, which this one is for November and December. So this little piece of paper was clipped from Astronomy magazine, but it shows very well the concerns about astronomy don't, the past isn't destroyed by the future. In other words, we keep the constellations, we keep rising and setting, and keep all these things as a growing sort of cohort of interesting things, and we don't tend to drop these things. But there is a danger to this, as I said, where people tend to think that if they watch Star Trek and know all the episodes by heart, then they're an amateur astronomer. So I don't know about that, but that seems to be a proposition that we could all have a little bit of an argument about, I suppose. Anyway, that's the end of what is astronomy and the early astronomers. So I suppose that, to sum up, all of the when you go outside and you look at Jupiter in a pair of binoculars, you're doing the same thing that was done by thousands of others going back hundreds of years. So, and Romer in the 1600s was watching the moons of Jupiter too. And he noticed that some of the moons, they go around in a predictable path, right? But some of them were late coming out around Jupiter. And that's because it took the light from Jupiter's moons, a certain amount of time to come from the moon to us. And so by looking at them going around and around and around, he was able to derive the velocity of light. Of course, the speed of light is very quick, and so attempts to find it on the Earth are very difficult, because if you turn on a light in a room and then hold up a piece of paper, obviously you can't see the light come from the light bulb and hit the piece of paper. It happens instantaneously. But over a very long baseline, like from here to Jupiter, it takes the light some minutes to make that transit. Romer was able to isolate and can calculate that because he had telescopes, right? But Jupiter, of course, has been watched a long time before that, and must have been a sort of an incredible event when, for example, there's a conjunction and Jupiter and Saturn are together. That happened in December 2020. I remember outside of my binoculars, I could see. Even in binoculars, Jupiter and Saturn were so close together that it was that they made a very tiny gap in between the two of them, which was and in my planetarium, I could see both of them at the same time in a very small field of view as they raced by with their moons traveling around them. Anyway, I guess so. Perhaps this is given everyone a little bit different view on astronomy than the usual have, and maybe that's the purpose of having a guest speaker come and talk to things that maybe haven't thought that much about. So anyway, I'm hoping that Hamilton will have good luck on the game on the weekend, and that Winnipeg. In fact, I'm looking at my astrological calendar here, and I say that let's hear. Oh yeah. Okay, so Venus is in Sagittarius. That's favorable for Hamilton, but Jupiter is in Capricorn, very bad for Winnipeg. So you heard it here first. The stars have given their verdict. Anyway, I'd like to thank everyone in the club for having me, and I hope everyone enjoyed this brief talk. Thanks very much. Yeah.
Bill, thank you so much for sharing that. That was absolutely fascinating. And one of the things as you were talking about John Dobson and talking to people as they're looking through the telescope and giving those little nuggets, I was reminded of I was up north at Bruce Peninsula National Park, and we were doing some outreach in the night. And the next morning, I was out on one of the trails, and I had this person from behind me say, "Excuse me, were you the lady with the telescope last night?" And I said, "Yes." And they go, "We recognized your voice. We have more questions. Can we just chat as we walk?" And you're right. People do love to do that and to talk about. And they have lots of questions and they want to ask. And it's kind of neat that we can connect that all the way back into the past.
Well, yeah, I know I've had similar experiences. I've been at a star party or something, and there's someone there with a telescope, maybe a family with a teenager, and they've got a telescope. And I say, "How did you get interested in this?" And they said, "Well, you know, about 10 years ago, someone with a big telescope came to a provincial park and set it up, and then we looked through it, and that's how we got interested." And then I say, "What park was that? Oh, and what year was that?" And then I'd say, "Well, yeah, that was me."
And it's really neat to make those connections. If there are any questions, you can pop them into the chat and I will ask Bill. And at this point in time, I see that Bernie is home and safe, and I will turn control back over to him. So any questions, put it in the chat, and I'll share them with Bill.
Okay, I see in the chat there are some things here. "Red sky at night, sailors delight. Red sky at morning, sailors take warning." That's a quote from Theo. For some reason, I can never remember that. But that is the quote, and that's from Theophrastus, the first writer that we made. And notice that they they form a pair: red sky at night, red sky in morning. So the night and the morning. So we're looking at the one horizon and then the others. They form a pair, and most of the things in Theophrastus do. And so this division, as I said, the division gets more and more complicated now, of course, with huge equipment, the massive telescopes. We can find, I say we can, but astronomers can find, for example, 1/100th of an arc-second difference, right, in two locations on the celestial sphere. So that's kind of like finding the apparent diameter of a Toyota sitting on the moon, right, from the Earth. So yeah. Okay. Yes, I think that in Matthew, maybe Matthew knew that too. Matthew lived after Theophrastus, so maybe he was referring to that. Interesting thing. Someone was saying in I think it's in Paul, but I'm not sure. But they're going on a voyage somewhere, and there's a pilot for the ship. And so someone came to me and said, "You know, did they have aircraft in the Bible times?" So I said, well, no, the pilot is someone who guides a vessel amongst waters that the pilot knows very well. So it's not an airplane pilot, right? They didn't have airplanes in the Bible times. Oh, I see. Okay, so I guess you got to go to an expert, right, to answer these hard questions. Okay.
I have a comment here, and it's from John Govero. You referenced Chaucer. Any other favorite literary astronomical references?
Well, Shakespeare is full of astrological and astronomical references. So it's interesting that the early writers are big on astronomy. And when you look at their astronomical references, they're always correct. But when cities began to be built, the writers got more sloppy with their astronomy. And one of them is Nathaniel Hawthorne, which I really, I like the Scarlet Letter and all that. It's really great. But there's a short story when he says, a group came, and this was at summertime. Okay, in the summertime, a group came, the full moon was out. And he says, and this was in New England, so the northern United States, not far from Hamilton in latitude. So he says the sun, the moon, the full moon was at the zenith, right? The top part of the sky in the summertime in the mid-northern latitudes. Now, of course, the full moon in the summertime would have a low declination. So could the full moon be at the zenith where we live in any season? No. So if this was true, then the people that he was writing about should have been speaking Portuguese, and it should have been in Brazil, right? So there's a mistake, right? Unless the full moon has some sort of symbolic meaning to the story, which I don't think so. Okay, but I think the answer to the question is Shakespeare has more. The faults are in ourselves, not in the stars, as in Julius Caesar, right? Or love is constant, right? It doesn't change. It is an ever fixed mark that looks on tempest and is never shaken. The star to every wandering bark, whose worth's unknown, though its height be taken. That's the North Star he's referring to, right? It looks down on tempest and it isn't shaken from its spot, right? So Shakespeare has a lot of that.
Bill, there's a question from Doug Curry.
Right.
How much progress is being made in finding the constellations of other people of the world?
Well, that's an interesting question, but remember, the constellation is made by us. It's arbitrary. So they're not discovered in the way that a vein of copper is found in the earth, or a new bird is seen in the sky. So the constellations are, well, there's a lot of them. I know in the planetarium that I have, they can show you different constellations from different cultures. So there's Chinese, they have 300 constellations. There's Arabic constellations, and there's First Nations constellations of various groups. It's important to remember that just like the words in different languages, there's not a hierarchy with the English word dog, right? That's not really, if you say dog in Portuguese or Saudi or something like that, you're not making a mistake. It's not that dog is its real name. The words are arbitrary. So the constellations are arbitrary, and the constellations don't really form the things that we think instinctively they are. For example, in China, the Big Dipper, which we see as a dipper, the bowl of the dipper is a house where the emperor lived. So that the bowl is itself a group. The emperor lives in there. It's like a house, and the stars on the end, the 3 stars on the handle, they are petitioners who are coming to ask a favor of the emperor. There's 3 of them, but the middle one has some writing. He has a scroll in front of him. He's going to read off this scroll, his request, and that scroll is Alcor. It's the middle star of the handle, of course, is a double. So that star is identified as a piece of paper being held by one of the petitioners. So it's totally different than what we think of. We think of it as a bear, and that's okay. And it was identified as a bear in many First Nations groups. But for anyone to say that there's some bareness inherent in the grouping of stars, that's not really the way it goes. So we know something about the constellations of other groups, but probably most constellations that were identified by most people over time have fallen out of memory, were never written down. And so it's difficult to reconstruct the constellations from sort of narratives way in the past, or sort of uncertain terms. For example, the Romans, they used the same word to describe comets and nova, right, and meteors, right? So when they say they've seen something, you don't know if it's a comet or a shooting star. Well, we got to know the difference, right? It's so you can't really get to first base when everything is so inexact as that. So it's difficult, but it is it is possible. I guess the best way to find out about these things is to go and ask people around the world. But sometimes they're hesitant about talking about these things because sometimes they're viewed as being private property. That's why the story of the pelican and the four winds, I didn't lift a First Nation star story and stick it in the talk. Didn't do that. I made up my own, right? So so I can't be accused of borrowing without permission or some sort of cultural appropriation, as they call that at the university. So I avoid that by making my own star myth. How did that happen? Well, the bag is in the Odyssey by Homer. There's a bag in the Odyssey, and then the winds come out of the bag and blow the ship away. So the idea of the bag of wind was there. And in some South American stories, rocks or other things go flying through the air, become red hot, and then show up as stars. So I put those in, and then the phases of the moon and the pelican suggested themselves. Also, the pelican is the color of the moon. So I just threw them all in the mix and wrote it down. There you go. So. So that's, but as I say, the concepts, no matter what culture you're in, people tell stories. No matter what culture you're in, people look at the sky. No matter what culture you're in, people have conflicts, right? And can view those conflicts up in the sky as sets of dramatic events, like the face-off between Orion and Taurus. They're supposed to be up there in combat in the sky. Or Orion and the Scorpion, which are on opposite sides of the sky. When Orion sets, the Scorpion comes up and takes his place. You know, in a planetarium, it's really easy to show that. So sometimes I just, instead of bringing up all the constellations, I highlight Orion and the Scorpion. And sure enough, when Orion goes down in the west at that moment, then the Scorpion will pop up on the other side of the dome. And I can point it out to the group that's in the planetarium. It's harder to see that in real life because you got to hang around and wait. So, but in a planetarium, of course, this is all quite easy to do.
Well, thank
Okay.
you, Bill.
What's that?
Thank you.
Okay,
I don't have
thank
any
you.
more. I don't have any more questions, Bernie, but I have a nice thank you from Doug Curry. So
Okay,
Bernie,
thanks.
I am going to give you. Oh, one just popped up. Hang on a minute, Bill. This is from John H. And
Okay.
I used to give students a star chart with no stick figures, just dots, and ask them to create their own constellations, and the results were fascinating.
I think that's a
that
very good
people-
idea. That's a
Yeah.
very good idea. Yeah. I'll
Yeah.
remember that. Yeah.
That's a cool
Yeah.
one.
Yeah.
Thanks, John. Okay, Bernie, I don't have anything else at this point in time, so I'll turn it over to you.
Well, thank you, and thank you for stepping in on short notice like that. I don't know if anyone was told how I ended up being late, but we'll go into that at another time.
I told them, Bernie.
Oh, okay. Well, good. Suffice to say that I made it here in record time. Thank you to the 407 and a very generous boss for letting me use it with the big truck. Let's see, Bill. I didn't get to introduce you. I'm sorry. I apologize for that. I take it that everything went well for you. I caught most of your
think so.
presentation.
Yeah.
Excellent.
Everything seemed to go well. We had, and it was streamed somewhere, so others can
Yes.
see it. Yeah, in other times. Yeah.
Yeah, I have some friends over in South Africa that are going to be watching it on YouTube.
Oh,
tomorrow.
okay. Yeah.
So,
Well, I think this
Um,
is this kind of tool is quite useful, and I think even when the pandemic finally goes away, well, we should still keep these types of things going, right? So I've given a talk to in St. John's, Newfoundland, from Vancouver, right?
Yep.
So anywhere, you know, the geography is I don't have to drive to Hamilton to give this talk, right? So
well, it works very well if you're in the West talking to the East, but if you're in the East trying to talk to the West, it's a little more difficult.
well, that's often because the West doesn't listen very well.
Well, that too. Doug Curry asked about, or was talking about constellations from other cultures, etc.
Yes.
Doug, you might check the Astronomical League. They have a program, an observing program called, where do we go here? Alternate Constellations Observing Program, where you sit down and you actually explore the different cultures and their constellations. You might have some fun with that. And something else that came up was you've been talking about astronomy before, telescopes and such, Bill. And I think I mentioned to you last night when we were speaking, they also have a program entitled Astronomy Before the Telescope.
Mhm.
So they talk about how they did all the measurements and stuff using sextants and the like. Okay, thank you again. If you care to, you're more than welcome to stick around, Bill. I'm going to go backwards here and I'm going to go into the intro before we go to the break. I'm Bernie Van Ness. Those of you who know me know my name and know of me. This is my second go round as chair of this organization. Happy to do it. My first go round was a 3-year stint that ended 3 years ago. So I'm back and I'm glad to do it. Let's see. Oh yes, Joanne. Are you here, Joanne? Yes, you are. Turn yourself on there, Joanne, or turn your, there she is. Do you have your piece of paper that I sent to you?
Turn your what?
Okay. Joanne just received, and I didn't have time to put it on thing, the Rising Star Award. So I will pass this over to Joanne right now. There you go, Joe. Congratulations.
Thank
Oh,
you.
yes. And did you get the nibbly with it? There we go. Yes, the Mars bar.
Thank you.
You're very, very welcome. Joanne is the third person in this club to receive the Rising Star Award and the first person to receive this iteration of the Rising Star. There are other people out there working on it, and I hope to see the list of recipients grow. As well, we have Joanne just received from me the Messier program list, and she seems a little hesitant to start that. But when I've told her that, hey, you're already 6 in at least with the program you just did. So it takes time. It's okay. You'll get it. Congratulations once again. Let's see. The door prizes. Now, usually we do door prizes right after the break, and we will do them after the break. But let me tell you a little bit about them this time around so that you can get an idea of whether or not you're going to come and pick them up, or if you want to pass on it, move it on to somebody else. There is a, oh hell, where did I put it? Let's see. Melissa,
Yeah.
could you do me the favor and just describe those books again? I lost my list.
Well, we were gonna do that when it was door prize time, but we can pop
Okay.
into that now if you want.
Okay, just a quick overview of them.
Okay, give me just a second here.
Okay, and while you're doing that, we'll talk a little bit about the food bank, which I've been neglecting lately, and I don't know, well, we haven't been able to make collections in the meetings for the food bank, but this time of year, more so than most others, it's noticed by families who are without. And it wouldn't hurt us to give a little bit that we can to the food bank or to your favorite charity. Do what you can. The loaner program, we have a good, vibrant loaner program. If you have a need for a telescope or you want to try a telescope, the different sort than you have, contact the family Whitman. She'll talk to you all about it. Okay, now, did you find your list?
Oh, we had them right here. We just weren't ready to, but that's okay. We're good. We're
Okay,
ready.
no, I was just going to try something different there to talk about them before the break, but
Fair enough.
whatever.
So we have a couple of door prizes here that are a little bit different than usual. We picked up some items, especially given that it's the Christmas season, that we thought would be more appropriate for the junior astronomers, or hopefully soon to be junior astronomers in our members' lives, or for the inner child in all of us anyways. So we have three things here that this is the one I'm thinking of that everyone's like, I want that, forget the kids. We actually found at a bookstore in Burlington. I'll hold them here, Mike, can you hold them up? I know the image is reversed, but HAA, the classic, The Stars. It's hardcover, brand new, and in case you don't know, HAA is also famous for writing the Curious George books. And actually, I remember the day shortly after we joined, Bernie had a copy that he gave to Maya, and she still has it upstairs. And I think he said it was his from when he was younger. So that was a very special moment. So as soon as I saw that, I was like, oh, we got to get that one. And then right beside it was, I know it's backwards, was Find the Constellations, also by H.A. Ray, in hardcover, fantastic condition. So we're going to give these two together as a set. So if somebody wants those, there's that.
Yep.
The second thing we found in the same place was this fun space matching game with featuring photos from the archives of NASA. There's some, just to give you a closer look, again, it's all backwards, but you'll get the idea. So a little memory matching game. Fun times. And this one is where I've had to be super strong when I'm talking about your inner child. The ultimate book of space with more than 40 flaps, pop-ups, pull tabs, and more. And I was a very, very strong girl to, I think, where's the astronaut here towards the beginning? I think I only, let me see here, pulled up the tab to reveal the astronomer or the astronaut inside just a couple of times. And, so most of the tabs are still intact. But yeah, so that's a fun little exploring book too. And those are here. So after the break, when we reveal some lucky winners, I will put the astronomy or the Loanerscope email into the chat for those particular people, and they can arrange to come and pick them up. And as always, first come, first serve. So the first, the first person to claim it in an email or whatever, and then when you come, it's there. So
there you go.
Yeah.
There you go. Okay, so that'll give you guys something to think about. Think who you might pass them on to, or maybe you just want to hold on to them yourself.
Mm-hmm.
Okay. Now I just got here, so I'm fine, but we generally take a bit of a break at this point, chat amongst ourselves, make a cup of coffee or whatever, and we'll come back here in about 10 minutes, 8:45. How's that sound?
Good.
That way I can start my dinner too.
That's good.
Good. Oh Lord, what a day. So Sue, the rest of the story, once I was coming back and I came flying across the 407, I ended up coming off the 407 at QEW there, and went to come across the Skyway Bridge, and it's just red lights from one end to the other, and I'm going, oh no! And the big sign saying the access to the Red Hill, all lanes closed. So I'm thinking, oh, this is going to be backed up forever. So I scooted underneath the bridge and came around that way. So, but as I looked up, I saw that the traffic on the highway was moving faster than me. I went, yes.
You know what, in situations like that, whatever decision you make is often the wrong one.
Inevitably.
You know what?
But I got here.
Yeah, you did.
So, let's see. Anybody get a chance to see the comet this morning? About 3 o'clock, there were some breaks in the cloud. No, of course not. Who was it? Denise was telling me that she had a chance to see it and didn't get it because it clouded over before they got the chance.
Yes. Yes, Bernie, we were there and so were the clouds. We scooted over there to that lookout across the bay, just 10 minutes from the house.
Yeah.
I even took my camera, wishful thinking. And there was Arcturus, there was Spica. And within minutes of leaving the car,
Clouded over before
the clouds decided to join us.
Oh, geez. Yep.
So, another day, another morning. And then, what is it? We were there and so were the clouds. We scooted over there to that lookout across the bay, just 10 minutes from the house.
Yeah.
I even took my camera, wishful thinking. I don't get why we're getting feedback here. Like repeating. And within
Actually, it was a loop.
the car. Yeah. The clouds decided to join us.
Oh, jeez.
I know that Denise and I are special and important, but I'm not sure why it's stupid.
Okay, so the weather forecast right now shows overnight Sunday being clear. So that means Monday morning would turn out to be probably your best bet if you're going to see it.
I tried yesterday morning and it was clear, but the light pollution was so bad that you couldn't see anything other than Arcturus. Like, it was just bad.
Yeah.
So I did try for like an hour and a half, and I had 4 different binoculars I was using, and there's no way.
Yeah,
well, if the weather forecast holds, I'm planning to be down at Hutch's by the beach.
Oh, that's another spot to go. Yeah, we just scoot over and go across the bay there, right here in the west end, down past Undering Castle.
Oh yeah,
nice hill and a lookout.
Right where you live, yeah.
Yeah.
But for me, it's just as easy to go out to Hutch's as it is to go over to Dundurn.
Yeah, you're in the middle.
Yeah.
You're in the middle.
So I don't know if everyone has seen, but Doug Curry has asked the group, how much are other people following the launch of the James Webb Space Telescope?
Well, that'll be what, in a week and a half, roughly?
Yeah, the 22nd.
Yeah.
Come on, it's going to be canceled. We all know that it's got to be canceled again and again and again.
Chris, don't say that.
Well, I'm wondering if once they launch this thing and it's in orbit, how long is the cloud going to envelop the Earth?
That's good.
It's going to take about 29 days to unfold completely. So it's like a month of stress and people just kind of hanging on with white knuckles.
Ah. Awesome.
I want a New Year's Day launch countdown.
Oh yeah.
Way better than the New York fall falling.
have the James Webb going up.
Yes.
And staying up.
Staying up.
Yes. Yeah, that's the critical part. Stay up. Get up and stay up.
I mean, if you follow the whole thing, you just laugh at all the little things that have gone wrong with it. Forget the big technical things, but like, who didn't figure out that if they flew it over, they couldn't get it from the airport to the launch site? So then they had to change and put it on a ship to take it through the canal.
Yep.
Like that wasn't even, had anything to do with building the telescope.
And then they had to escort it because of piracy.
That was
Oh,
another.
yes, absolutely.
Yeah.
There's no piracy. There aren't any pirates in this world.
It's had quite the adventure and it hasn't left the earth yet.
I know.
Watch for it to show up on eBay.
Oh,
Oh, yes. Well, how many times have you gone on field trips out to different events, and the trip is the highlight of the event, right?
It's all about the journey.
It's all about the journey, because when you get there, of course, it's raining or it's cloudy or it's tornadoes or snow or whatever, but you had a blast anyway.
Well, if this is successful, like we're watching history, so it's pretty cool.
Yes.
I like the name. It's a web, all right.
Oh, boy, boy, boy.
Well, I'm gonna go make a tea.
So let's see. Oh, yes. Now, yes, Joanne received a certificate just now, and I received one just the other day. I showed council, but I didn't show the rest of the club.
I can't see it. What's it say? Binocular Solar System Award.
Yes,
Bernard,
that's me.
congratulations.
Thank you, thank you. And
What did you
That's-
have to do for that one?
the toughest, well, you start off with observing where the sun rises or sets in the spring and in the fall, so that you can see, determine how quickly the sun moves across the sky through the different seasons, is one of the things. The most complex part of it was observing Jupiter for 17 days.
Oh, wow. Without cloud cover.
Well, you try for as little cloud cover as you can. The whole idea is to track the motion of the moons, and then from sketching where the positions are through the different days, you can determine the orbital period of each of the moons, approximately. Let's see, what else was there? Of course, finding Venus and Mercury and Neptune and Uranus, those things as well. Oh, and the comet. That's pretty much it. There's a couple other little things, but I can't remember what they are right now.
Did you have to find asteroids?
Yes, on this particular event, no, not on that one. I am doing an asteroid award program right now. I'm sitting at, I think, 94. I need 6 more.
Wow.
With that. And I've been working on that one for about 9 years. So a little 2-year program or 3-year program is not a big deal. It is to the people doing it, but the whole thing is, the idea is to maximize your time.
Yeah, that's dedication, boy.
Yeah, well, it's commitment. Some people say I should be committed for it, but
Bernie, it's time for us to get,
is it?
yep, or it's time to move on to our door prizes.
Awesome. Okay, it's time for the giveaways. We'll start off with the 50-50. Oh, never mind. I won that.
Timeline, but when do we tell the whole group about the whole proposal?
They screwed up.
People say be committed for it.
Or you
All
can
right.
text- I think that's the same thing she texted. She tended to.
Bernie,
Hello.
it's
Listen,
just
Denise,
me.
your mics are on again.
Door prizes. I'm just going to ask everyone to mute
Okay.
their mics, please. We're getting a lot of feedback from different places, so If you could mute your mics, that would be awesome.
But when do we tell the whole group about the whole proposal?
Screwed up.
It's because someone has YouTube in the background.
All right. I think that's the same thing. She turned it on.
Hello.
The mics are on again.
Okay, Sue, can you shut everybody's mic off?
I think I fixed the problem.
Thank you. All right, Family Whitman. Where are you? There you are. Maya and company and Melissa. Where's Brian?
We're here. He's
Studying physics. He has
he's
an
got a
exam.
physics exam tomorrow, so
Oh, well, okay. Well, we won't bother him.
but he says hello to everybody and Merry Christmas and Happy Holidays and all the hoopla. But yes.
Good stuff. Okay, have at it, ladies.
Okay, so we have some names here. Feel free. We've pulled a couple of extra numbers. If you feel you want to pass on these particular door prizes, let us know, and we'll go on to the next person in the list. But as I said, once we've got our 3 names established, I'll put something private in the chat to those people, and we'll make a plan.
All right. So for our first name, we have Linda C.
Linda C. Are you with us? Turn your microphone on and say hello.
Hello.
There she is.
Hey, Linda.
Hey.
So yeah,
I'll wait and I'll defer to whoever wants to choose first because I'm not particular. So I'll just wait until the end.
okay. So what I'll do is because we won't do it here in front of everybody, but I'll just
Yep.
send out the emails and I'll let you know what's left after the 2 people choose.
Okay, terrific. Thank you.
Congratulations.
Thank you.
Next, we have Tom Hansen.
All right, same thing, Tom. Turn your microphone on. I see you up there. Turn
Yeah.
your microphone. There you are.
I'm on, yeah. I
Hello.
would like,
Congratulations.
thank you. Can you hear me?
We can.
Yes.
Okay, good. Yeah, there's 2 young ladies living next door to us that are really, really interested in astronomy. One girl is in grade 3, the other's in grade 2. So I think I would like the HAA books,
Awesome.
if it's possible. Yeah.
Perfect. Yeah. Excellent. And then the next person on the list is
Lastly, we have Bernie.
What?
Yep.
I'm not here. I'll defer. I'll pass on it.
okay.
Okay.
you.
Then we have Jerry Haslam.
Jerry
Said that right.
Yes.
Haslam.
hello.
How do you
Hello.
pronounce your last name, Jerry?
Haslam.
Haslam? Thank you.
Yep. No, I will pass and hope for something another time.
Okay. Thank you for letting us know. That's great.
And then I guess after that we have John Govro.
The dice have chosen well tonight.
Hi. Yeah, I was going to say the same as Bernie. I'll certainly, toss my prize back into the ring to let somebody, maybe somebody with some little ones at home have a shot at it. Thank you, though.
Okay.
Then
well,
we're gonna have to pick another name.
Yep. Okay, so I gotta get my dice and roll again. Really helpful if okay, 20, 28,
Participant
20.
Participant number 20. Joanne. It's all about Joanne.
Joanne, there you go. Joanne gets to play with the pull tabs.
This is awesome because the neighbors across the street, I actually showed them Jupiter and Saturn through my telescope this past summer for the first time, and they were just like gobsmacked. Like they were like, "Oh my gosh, Saturn actually does have rings!" So yes, I would love to have one of these prizes. That's great. It'll be a great Christmas gift for them. Thank you.
Fantastic. And I see Linda in the chat is also passing on her win to someone else. So thank you, Linda. If that's great, if you don't have anybody particularly in mind. So let's drum roll. $18. I thought we just did it. Oh, we did 20. So
20 you did.
Chris Stretch. Chris, are you with us?
I am. I will also defer. I have no little ones.
Oh my
The only
God.
little ones I have are dogs, and I don't think they'll.
They'll just
they'll
shred
eat
it. They won't appreciate it. Okay, let's keep going.
$31. We have Steve German.
I knew I would win eventually. I'll take it.
Yay! There you go.
Send me an email and I'll pick one of those gifts for one of my grandnieces.
Excellent. So Joanne and Steve, you can cage match it for the space memory match or the ultimate book of space with the pull tabs. And then you're both on council, so you can just contact me via council which one you want.
Okay, very good.
Fight it
I
out
expected
right now
to win.
in front of all of us so we can watch, because that would be amusing. Take bets. We'll start a pool. Who wants what and who's gonna get it?
Well, I'm sorry, guys. We were right at the very edge. If Steve had passed on that, I was going to implement executive authority and award it to you guys.
Oh. Okay,
But
Joanne has
we'll
played
find
the full
something for
tab,
you
so
if-
Stephen, you get the memory match. It's all settled. Awesome.
Okay, good to know.
Fantastic.
All right.
Yay.
Woohoo.
Yay, everybody.
Merry Christmas.
Congrats.
everybody.
Don't
Happy
forget to get
holidays.
them.
Thank you.
Okay, so, which brings us to Mr. Mannering. Matthew,
I am here.
how are you today?
I'm good. How are you?
I'm starting to settle down. You know, the body's still going with the truck, but we're getting there.
Okay.
Hey, come on. North Bay and back in the day is a bit of a blessing.
I've done it. It's not fun.
Yeah.
Okay, I'm going to share screen.
Okay.
Share. No.
There you go.
It's always good to start at the beginning.
There you go.
Yeah. So welcome to the sky this month for December of 2021. I'll start with the lunar eclipse that happened back on November 19th at the very, very horrible time of 4 a.m. is when it peaked. That's maximum eclipse. So I personally got up at about 3:45 and didn't expect to see anything because the clouds were everywhere. But it turned out there was a hole in the clouds. And so I got my 300mm lens and leant up against the truck, and I did some handheld shots of the moon. It was cold, the wind was blowing, it wasn't nice, but actually the moon looked pretty cool. And it was really, really dark for some reason, as in as dark as this or even darker when you looked at it. This one on the right that I've taken as well is more like what you would normally see, but it was extremely dark. These are from the same night, and one is just differently exposed than the other to bring out the shadows a bit more. The beautiful crater with the rays on the edge of the dark area is Tycho. This is what happens when you hold the camera steady and you're trying to shoot a picture of the moon. So don't do that. And this one here is from Bob Christmas. And what he did was he caught the moon as it was passing the Pleiades, this star cluster over here. And what he did was he took two images, one to bring out the Pleiades and one to correctly expose the moon, and then he melded them into one image, and that gives you a nice balanced view of the sky at that point. So it's a really nice shot. As always, if you have a lunar eclipse, you're going to have a solar eclipse, and 2 weeks later, there was a solar eclipse. Unfortunately, it was over the Antarctic. This dark color here, the dark sort of reddy pink color, is the area of total eclipse. You can see it goes over Antarctica and the Weddell Sea, and then it's starting or ending, I can't remember which, but between the South Georgia Islands and the Falklands there. So very few people obviously saw this, but there were a couple of planes that were chartered that went to see the eclipse, and you can actually see the other one in the distance there. You can see the sun is eclipsed. You can see the shadow of the moon in the sky and on the earth. It's really a nice picture. It must have been quite the experience. Down on terra firma, on the Union Glacier, this fellow Andreas Moeller got a shot of the eclipse, and it was really very good. Apparently it was -20, and that of course is coming into spring, summer there. So yeah, I don't think it was that pleasant, but they're used to it, I guess, down there.
That is a fantastic photo.
It is. And this one here is from the Discover Climate Observatory satellite that's way out in space there at 1.5 million kilometers. And this is the image it got of the eclipse. Here you can see the umbra and the outer penumbra there. And the actual site where everybody else was actually around the curve of the Earth on the far side there. But it's really a cool image, and I thought it was worth showing. Now, Comet Leonard is supposedly peaking in the next couple of days. It's been quite difficult to see. It's nothing like Neowise last year, but it is going to get a little bit brighter. The actual maximum is around December 12th, and it should max out about magnitude 4, but that means you still have to be in a fairly dark location to get a good view of it. It's not going to be back for 80,000 years, so don't worry about it. Don't hold on to your camera too long. And by December 12th, that's sort of the crossover point as well, where it'll be in the early morning sky and in the sky at dusk. So after the 12th, you're probably better off to try and look for it at dusk. And this image here is an updated image just from yesterday that a fellow took from Arizona. So this is a light curve for the comet. They generally do this for any of the brighter comets. The blue line is the expected increase in light, up to a maximum here of about 4.5 magnitude. And then it shows as it gets further away, again, you see the brightness falling off. All the little plus signs, those are actual observations right up to today, actually. And you can see that the light curve predicted is pretty much matches the actual. So I think we're pretty much set on this being pretty much the max, somewhere around 4 to 4.5. And it's only going to be like that, as you can see, for a couple of days. That's it, and it's going to start to dim off again. Now, last month I did talk about a couple of really interesting objects that the Leonard was going to pass. And one of them on November 24th was the Whale and the Hockey Stick, 2 galaxies. And this person here, a really nice picture of it. There's the whale, there's the hockey stick. And they're really quite bright galaxies. They're small, but I can see them. I've seen them in my 12-inch Dob, so it's kind of neat to see it in the photograph too. And on the 3rd of December, it passed M3, which is a very beautiful globular. It's one of the nicest ones in the sky, in my opinion, and it's quite a good size. And Leonard was going to come down from the top of the screen and just brush the edge of it. And here's an image. I think it's a fabulous image of M3 and Leonard, taken from Italy. Now, Anne got out yesterday morning, I believe it was, and she looked for the comet. And from Hamilton itself, where obviously there's a ton of light pollution, she took some shots, and actually, even with all the light pollution, managed to get the comet very faintly right there. But it's extremely difficult from in the city. And by the time you expose enough for the comet, you've totally wiped out everything else in the sky from overexposure. So again, you have to go out into the country to get a better photo of it, but at least somebody got a photo of it. So that was good. Now, starting on the 12th, that was the day I said you could see it in the morning and in the evening. On the 12th at 5:30-ish, Leonard's going to be in the west here. Very low, like at 5 degrees. So you're going to need a very, very clear western horizon to be able to see that. And it's joined by Jupiter, Saturn, and Venus over here. And it should make quite a nice sight. Unfortunately, Leonard is setting, so at 5:30, that's about the height of it for that day. 5 days later, on the 17th, it's actually moved all the way from over here off the screen all the way across to the left, and so it's directly under Venus. So you'll have a better chance of seeing it because it'll be further away from the glare of the set sun, and it'll be basically almost halfway between Venus and the horizon. So you can have probably your better shot at seeing it, assuming that you can actually see anything at all, will be probably then. And then on the 25th, if you happen to have some time in the evening, then Leonard is way over here in the southwest. Between Saturn and Jupiter's up here, you've got to come down. It's at about 8 degrees above the horizon. You should still be able to see it. It'll be about magnitude 6. You're going to need binoculars. You won't see it naked eye, but it will be there. And Jupiter, Saturn, and Venus are joined by Mercury, which is really, really low on the horizon. It's not a good apparition of Mercury for Northern Hemisphere this time, but if you've got that clear Western horizon, you should be able to see it. And just wait for another hour on Christmas evening, and you might have a chance to see another comet called Borrelli. There's been quite a few pictures taken of it on spaceweather.com. It shows up really nice in the pictures, but of course, those are long exposures. It's going to be about magnitude 8.5. You'll need, I would think, good sized binoculars. I'd want like 70 millimeter or larger objective lenses on them to have a really good chance at seeing it. But it's almost due south at an altitude of 25 degrees, roughly. And so to find it, you can probably draw a line from Fomalhaut, which is the only star in this sort of south-southwest portion of the sky, and this star up here, which is, again, the next brightest star over. Go about 2/3 of the way in that line with your binoculars. You may be lucky and pick it up. It's completely, you know, up to the sky conditions and just how well Borrelli is holding up in terms of its visual magnitude. Now, last month, I was going to talk about this particular cloud of gases and dust called NGC 1333. And about 5 days before the talk, I had seen a picture of this and was absolutely blown away by it. So I did a bunch of research. And then on the day of the talk, I actually looked again for more information, and it was the APOD, the Astronomy Picture of the Day, somebody else's picture of it. And I was a bit ticked because it's another example of where you look stuff up and then somebody else does it anyway. But anyway, so this is the object. It's a fantastic object to look at. The upper portion in this picture here is a reflection nebula powered by that star probably right there. So the star shines in behind the nebula, and light is reflected off of the dust particles in the nebula. And reflection nebula are always blue, and emission nebulae are always red. So you can tell by the color what type of nebula it is. In the lower part here, which is extremely heavy, filled with dust, you can see all these bright patches in here, all these ones here. Now, those are all star-forming regions within the cloud. And what's amazing is how well they pop out from the dust. Normally, you won't see hardly anything that's inside the dust cloud because it's totally obscured. And another interesting thing about this is that a lot of these objects in this location are called Herbig-Haro objects, and it's the densest population of this type of object in the sky. And there's like 100 of them basically in this volume of space. So a lot of you won't have a clue what a Herbig-Haro object is. So a quick little guide to that. So these stars, as they're born, they're very, very young at this point. And they have a very thick, what's called accretion disk around the star. And this is all materials that at some point may or may not evolve into planets and moons and such. But at this point, a lot of the material is still being pulled down onto the star. And there's so much hitting the star that, and don't ask me to explain the physics, but it can't sort of take it all in, and it shoots some of it up, the gas especially up from the poles of the star, up and down like that. So you can actually tell which way the star is spinning. Generally, it's, you know, it's going to be this way or that way because it follows the accretion disk, and this is at right angles. These things here are bow shock waves that every time the gas from these jets hits sort of a different density of dust and gas, it creates this bow wave, this shock wave as it goes along. And then it leaves it there sort of as an imprint to show you where it hit. So in this actual image, which is Hubble, it's a Hubble telescope image of Herbig-Haro HH111. And here's where the star is. Notice you can't see it. It's very rare to see the star in one of these objects because the accretion disk is so thick that it just obscures the star. But here's the beautiful jets coming out of it. And you can actually see these little curved parts right there, there, there. Down here, there's a few down like that. These are all points where the jet of gas from the star has hit a denser, probably, or a region of dust and has created this visible bow shock wave. It's really interesting. And this particular HH star, Herbig-Haro star, is in a molecular cloud called L1617. And if you're like me, you'll never remember that. But this one is actually in Orion, within this circle right here that I've got. So between Betelgeuse and Alnitak, almost on the line, is this area here. And that's where that molecular cloud is with that particular Herbig-Haro object. Let's go back to NGC 1333 now that we know what these Herbig-Haro objects are. And now you can sort of appreciate more. What you're seeing is the birth of all these extremely young stars here. It's just a fantastic image. And this is basically about the stuff I've already talked about. But it says basically there are hundreds of stars less than 1 million years old, and most of them are not visible in, you know, in the spectrum we can see. And it is at the edge of a molecular cloud in the constellation Perseus. So to show you where that is, Perseus is here, right? Triangulum, Aries, Auriga, Taurus. There's the Pleiades. There's the California nebula right there. And the region we're talking about, this Perseus molecular cloud, is in this area here. Now, like the California nebula, it's not visible to most people. You'll never see it in your telescope because we just can't pick up the light at that frequency. But this is a fantastically huge region and looks like this. What you can see maybe optically is this little area here and this one. The fact that this has an IC catalog number means that, yes, you can see it with some sort of telescope visually. And this one. And this is the one we're looking at, 1333. Now, I've tried for a long time to see, you know, gather more information about the stars in this dust cloud. And so eventually what they did was they combined observations. So the Chandra X-ray Observatory is this image on the left. And the way it works is all of these stars are within that dust cloud. There's 92 of them or something. And what's interesting is because they're all close to each other, the actual relative brightness of the X-ray emissions gives you an idea of the relative size of the stars in the cloud. And then they join that with Spitzer Space Telescope infrared emissions coming from within the cloud. So all the hot areas where the stars are forming are going to be the brighter red zones in there. Notice that there is some sort of correlation between the two images, but it's kind of hard to tell. And then they use the visible spectrum that, you know, just a regular photograph. They took one of those from Kip Peak, which is very similar to the one I showed you. And then they combined all the images here. And what you have is this sort of multi-spectrum view of what this particular molecular cloud looks like. And you can see quite deeply into it, and you can see the X-ray type stars combined with the infrared image and then the visual of the reflection nebula. It's kind of interesting. So Spitzer also did had another go at it at different frequencies in infrared, far infrared. And has somebody got their mic on? They are really having trouble talking over that. Anyways, what you'll notice in this particular image here is these greeny yellow like knots that are all over the place. And I'm going to read this because I want to get it right. Knotty yellow-green features located in the lower portion of the image are glowing shock fronts where jets of material, in other words, Herbig-Haro objects, spewed from extremely young embryonic stars are plowing into the cold, dense gas nearby, gas and dust. The sheer number of separate jets that appear in this region is unprecedented. So it's just chock-a-block with Herbig-Haro objects, very young stars, all creating jets. And I zoomed in a bit here so you can see them better. Now you don't see the same detail as you did in that other HH111 because, you know, this is a wider field, but all these streamers here are streamers created from these Herbig-Haro stars that are spewing out jets of material from their poles. And lastly, I've been looking at clocks on the internet because I've got some automatic clock watches, which are, you know, the ones you wind with your wrist, and I've got a pocket watch that I sort of inherited, and I find the mechanisms fascinating. I don't understand anything about them, which is why I went online to sort of look for them. Anyways, I found this this astronomy clock, and the website is mytimemachines.net. So if you want to write that down, that's a place to go, mytimemachines.net. This is for anybody who loves clocks, astronomy, gizmos, anything like that. So this particular design was requested, and there was a clock maker that took it on, and they wanted it to be classic in design, but they also wanted it to do a ton of stuff. So part of the design is based on Harrison's H1, H2 clocks. They were the first ocean-going clocks that could keep accurate time, so you could determine your longitude, which kept you off the rocks and kept your ships from being torn apart, that kind of stuff. You didn't get lost. There are 52 or 50 plus complications in this clock, and a complication is anything other than basically the time. So if it's got the date, the month, the year, anything like that, that's extra is a complication. And 52 complications is huge. And some of the things that are included on this clock are a 400-year perpetual calendar, equation of time, sidereal time, sun and moon rise and set, moon's phase and age, tides, solar lunar eclipses, a planisphere, a tellurium, and a full-featured orrery to Saturn with functional moons. Altogether so far, actually it is complete as of last month, took about 12, 13 years to build, 7,688 parts, which is just astounding. And there are some very complicated clocks out there like Harrison's, which I've seen run at the Greenwich Observatory a bunch of years ago, but I actually got to see them run, which was very cool. The one thing I did not know what it was or have any clue is the thing I've put in bold here, a tellurium. When I looked up tellurium on the internet, I got that it's a element in the periodic table, number 52, which, yeah, and that's what I got. And then I couldn't figure out how to call up and find out what tellurium was that had anything to do with astronomy, but finally I happened upon it. And the way it should be spelt is tellurion with an N, but it can also be called a tellurium. So I think that whoever designed this clock and, you know, specified what they wanted, thought that'd be kind of cute to have all these complications that match an atomic number of an element that also could be a thing to do with astronomy. So what it is unlike a full orrery, which has the sun and all the planets and their moons going around, it's a mechanical device. This one concentrates on the sun, the moon, and the earth. And so it's the path of the earth around the sun and the path of the moon around the earth. And that's a tellurium. So kind of, I learned something there for sure. This is the actual clock. It stands about 3 feet high. At the back, you have these oscillating counterweights that go work opposite each other. That's sort of from the Harrison design. And then you have all these dials here and stuff. This is a planisphere down here. This is the tellurium here. There's the rise and set times of the moon and sun over here. And there's international times. And if you can imagine it, it's here. And it's got about, I think about 8 or 9 different points where you wind it up to make everything work. But here's a couple of close-ups, the sun, the earth, the moon, showing which phase we're seeing from the earth. And over here is the planisphere. And it's really cool because they can take this clock and they can run it in demonstration mode, slow or fast. And so they can speed the thing up, and all these things spin like crazy. It's really worth seeing, like watching some of the YouTube videos to watch this thing go. Here's a view from the top. There's the orrery, which is the view of the solar system mechanically. And here's a closer up. Saturn is here. It's got 5 of the moons, and they all rotate around Saturn at the proper rates, so you know where they are. Jupiter's 4 Galileo moons and the inner planets. So pretty darn cool to watch this thing go. Here's sort of a side view. These are the main bells that ring the hours and the quarter hours and all that kind of stuff. Beautifully tuned. You can hear them on some of the videos. And as you can see, it's incredibly complex. It's made to run, most of it is made to run dry. It requires very little oiling, which, as you can imagine, oiling this would just be a nightmare, right? So it's meant to run dry, and it has just been delivered. So it's mytimemachines.net. It's really cool. Astro Skeleton Clock. If you put that into YouTube, it'll come up. And also you'll find out more on the website. It's just something totally different to present and to think about. And really, just once you start watching the video, you won't be able to stop. And that's all for this month. As always, from Janice and I, best of the holiday season. Everybody stay safe, stay well. And I'll say the same thing that I said last year, right at this time. I hope that in the coming year, we all get to be together and have a meeting live, which would be just awesome. But still going to be a while yet, I'm afraid. And that's it for me.
Well, thank you very, very, very much, Matthew. Entertaining as always, educational as always. Does anybody have any questions for Matt?
Does that come in kit form, Matt?
What was that, Ed?
I say, does that come in kit form?
I can understand. Oh, I've got Doug Turner asked how much it costs. That and the actual owner have not been identified. I would imagine that I've seen 30 complication pocket watches that have gone for around $30 to $35 million in auction. And this sucker's, twice as complicated with way more parts, and it's huge compared to a pocket watch. I would think that you'd be in the, I have no idea, 20, 25 million range anyways, because it's a little easier to work on something big than something tiny like a pocket watch, but it's got to be humongous money.
Yeah. Yeah, it would
So
be.
there's another question there. How many people built the clock?
It's actually done by a fairly small clockmaking facility. I don't think there was more than about 7 or 8 people involved in it. It would be my guess. And what they did was they made wooden models, then they they printed plastic models to see how everything fit together, and then they built it in sections. So the orrery or the tellurium or the multiple time zone face, all these things were built in sections and tested, and then they had to fit them all together. So there had to be a master plan of how it would all fit together. it must have been just brutal to try and do. Just brutal.
I can imagine that if you had too many people, it'd be just too many fingers in the way.
Yeah, it literally would. You've got to have a very small crew that really understands how these things work. And like I say, the cost must have been just out of this world.
Astronomical. Ha 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 ha.
Yeah.
Thank you again. Let's see. Family Whitman is asking to pop in for a second. Please do.
Hey, Bernie. I just wanted to reach out to, excuse me, sorry. Tom, I sent a couple of messages in the chat about the door prize in my email, and I haven't heard back from Tom, so I want to make sure he sees those messages so that he can get in contact with me and we can get that to him. So Tom, if you're hearing this, do check in the chat, please, and the email is there for you to reach out to me.
There you go. Thank you. And thank you. Oh, I've got a big list of thank yous today. First off, thank you to Sue for all she does for us, including covering for me when I'm stuck on the road. She's takes care of all the buttons here to turn people's microphones off when they forget to do it themselves. Thank you to Bill Burnett. I think Bill has left us earlier. I imagine so, because it's probably dinner time out there now. To Maya and Melissa and the family Whitman, thank you. And Matt, thank you for your contribution as always.
Welcome.
And from me and the rest of council to you and yours, a very Merry Christmas, Happy Hanukkah, whatever it is you're celebrating, celebrate it in peace. Next month, we will have Dr. Paul Delaney come to speak to us on the ins and outs and values and of occultations. So that should be very interesting. Anyway, I will see you folks next month. Have a great day.
Yeah.
Good night, all.
Good night. Stay safe.
Merry
Happy
Christmas.
holidays.
Matthew.
Good night.
Merry Christmas. Happy holidays, everybody.
See you next year.
Thank you.
Great job, Sue. Great job.
See you next year. Good night.
Thanks, Matt.
Good
Yeah,
night.
see you
Thank
next
you.
year,
Thank you
everyone.
very much.
Thanks. Good night.
Happy
Good night.
holidays.
Happy
Bye.
holidays.
Merry Christmas.
everyone.
Bye.
Happy holidays. Merry Christmas.
Yeah.
Happy New
Merry
Year.
Christmas. Good
I've
night.
been cut off.
Bye, Sue.
They cut me off.
Leon.
They cut my face off.
Oh, Tom, hang on. Let's see if I can fix that.
Yeah, thanks.
I'm going to ask you to start your video. You'll get a little message.
Okay.
Hey,
Start.
There you go.
Okay. Yeah. I need to get your address so I can come and pick them up.
Okay, so are you able to access the chat?
No.
Okay, so do you see on the bottom of your screen where it says chat?